Welcome in this second episode of Design Series, Create a Computer Case for a NAS with SOLIDWORKS xDesign. The goal of this video series is to show how to design a fully functional computer case, and today we will focus on external structure of the NAS. If you haven't watched previous episode, you will find a link in the description. Now I have built a rough layout of my components. I need to create a box around them. There will be some bars on external edges, and I would like these bars to adapt to computer component positions until I know how they are arranged inside the case. I would like xDesign to adapt bar lengths and corner positions for me. Once I decide component layout is good enough for box size and airflow, I fix bar dimensions by removing external references. Exactly what a design engineer would do in an industrial company using SOLIDWORKS xDesign. So let's start this external structure with a corner part. As always, I begin with a simple sketch and make sure dimensions and relationships are added so I can change my geometry in the future with no risk of error. I create first extrusions for this corner and some recesses for the plates that will close the volume. So the plates will be put in position before I add bolts to secure them. As any designer, I need to put in position before I add screws to hold parts in place. I finish the recess design with the last face, and I make sure I choose the right starting plane for each sketch. Then I add some chamfers for style. It will look far better like that and will remove some sharp edges. To open easily my box, I will put some embedment nuts, and for that I need these holes. Nuts will be inserted with a soldering iron to stay in place, and of course I need this hole in all recess. That's where mirror feature kicks in. I finish outside shape with a fillet and place my part on the box I told you about in the last episode. This box represents the space needed for my computer components with simple parameters like a rectangle and an extrusion. I just need to add simple mates to this box, and I know there will be no interference with my components. To speed up positioning of other corners, I leverage copy with mates, and my 8 corners are in place. Now I create a cross parts in the middle of my assembly, because length of my parts are limited by my 3D printer capacity, so I cannot create only one vertical bar. This cross part will look like the corner for the recess and the chamfer, and of course I choose same dimensions for width and for nut holes. The only difference will be the bosses for long transversal parts that will add strength to the whole assembly. I choose slightly bigger dimensions to make sure these parts are really strong and won't bend. Of course, there will be smaller parts on front and back side, and these parts will have same sketch dimensions to keep unity in the design. I finish with a fillet, leveraging edge order to go faster. Then again, I mate cross part with my extrusion. Here I leverage the symmetry of my model. This will ease mating operations, and of course I also use copy with mates to expedite positioning of other crosses. For that step, I just need to select references used for mates of the seed part in the same order but for the new position. Now that all joint parts are created and placed, I create bars but with up to reference so they will adapt if box changes sizes. For sketch, I leverage existing geometry to save time during this pre-design phase. Nothing is set in stone yet, so I don't spend time defining things that may change in the near future. Again, something that a designer would do in an industrial company. I copy the part with mates and start doing the exact same operation with middle bars on the side. Retrieve the sketch from the cross part, create a middle extrusion up to the cross parts to adapt if anything changes, and add mates to this transversal part. Remember to mate parts you create with external references. External references are never enough to fully define position of a part, and it could lead to issues when a drastic change occurs. I do the same for topside bar, following the exact same process for the sketch and extrusion end conditions. I copy the top bar on the bottom with copy with mates, and I'm ready to mirror those parts on the other side. As I anticipate some changes, I create a mirror for the top bar so there will be 2 separate objects. You will see why in the episode about motherboard positioning. Only vertical bars are missing, but because everything is symmetrical, I just need to create 1 bar. I start with positioning planes in the middle of each section And as I did before, I create the bar with the sketch taken from the corner part and an extrusion up to each part to adapt for changes. Nothing new here, I leverage copy with mates to add 7 additional bars to the model. When the reference I need to add is the same than seed part, I just check the box, reuse existing reference, and job is done. Now that all bars adapt depending on extrusion size, I can arrange computer parts the way I want. Extrusion will change, and that will change the full structure in a couple of clicks. This is how I define how I want my part to be positioned, and that defines size of my structure. That concludes our episode today. In the next episode, I'll focus on designing fittings to connect these parts seamlessly, ensuring they stay securely in place, and some markings to easily distinguish between parts with similar dimensions. As always, in the meantime, you can check SOLIDWORKS Maker's website to learn more and subscribe to xDesign for a cheap price. Thanks for watching, and see you in the next episode.